Okay, let's do video number 2 for chapter 15. We're going to cover photochemical smog. It begins on page 417 in your textbook. Let's do it. Alright, you have got this diagram in your book, and it's a very important diagram for you to understand. This is entitled photochemical smog, and as the name indicates, light is involved here, and it's the light from the sun. This is also known as brown smog. Brown smog. Note the difference, please, for future test purposes. Brown smog. And what is brown? The brown is the nitrogen. The brown is the nitrogen. Just so you can remember that. But the pollutant, the problem with photochemical smog, is ozone. As we mentioned last time, ozone in the stratosphere is good. Ozone in the troposphere is bad. It is a serious lung irritant. It causes breathing problems, and that's the principal pollutant when we talk about photochemical smog. But that's at the end of the line. You need to know what the principal cause of this thing is at the beginning of the line, and it is the nitrogen dioxide. It's the nitrogen dioxide that is the principal starter of this problem. And where did I tell you to remember nitrogen comes from? Cars. Photochemical smog is a car problem. So places that have lots of cars are prime, and lots of sunlight are prime victims of photochemical smog. It's called brown smog or brown air smog, and it's caused because of a photochemical reaction. And here it is. You've got to learn this. You've got to. This is every bit as important a chain of events as eutrophication is for your exams. So you're going to have to remember it. Here's how it goes. The NO2 is released into the air primarily by cars. Oxygen that's in the air sometimes gets broken up. Or sometimes we have just a monoatomic O. In the case here, it's showing you that the sunlight breaks down. Notice the sunlight's an important part of this. That's why it's called photochemical. The NO2 in the atmosphere gets split up into NO and O. But this free O ends up reacting with O2 in the atmosphere to make O3, which is the ozone. Alright, so you know that chain of events. It all starts because of cars and the NO2. Of course, there are natural sources of NO2 in the air, but by far photochemical smog is a problem because of vehicles. Nitrogen dioxide. In the presence of sunlight, this doesn't happen much in cloudiness, but in sunlight, one of the O's is cleaved off of an NO2 and reacts with O2 to form O3. Big problem. Alright, so a city that has a photochemical or brown smog problem has lots of cars and lots of sunshine. LA, perfect example of a brown smog city. And now you know why over the last 30 years California has been pushing air quality standards more than any other state, because they are damaged the most. Remember the third thing that has to happen with photochemical smog. It's not just the sunlight, it's not just the nitrogen dioxide, but there also needs to be some sort of a physical barrier that keeps the ozone from just floating up into the atmosphere and blowing away, which can typically happen in a lot of other cities. There needs to be a mountain range or something. The topography of the city matters. In California, it's that mountain range. And so this isn't just an LA problem, because there are car issues all up and down California. That's why the whole state is concerned about photochemical smog, also known as brown smog. Guys, this problem gets so bad that they actually, when you watch the weather forecast at night, I know I used to live in California, when you watch the weather forecast at night, they tell you what the air quality index is for tomorrow. You know, they give you a 0 to 10. 10's a good day. You know, 0's a terrible day. There are actually days, because the air isn't moving, there's no flow, and because it's a weekday with lots of cars, and it's in the summer with lots of sunshine, that they actually close schools, because the air quality is too bad to let little kids go out in. We don't want an asthmatic can easily have an asthma attack because of breathing in brown air smog. They tell old people, stay home, don't go outside. Because if you have a lung condition, if you've got emphysema or one of those other problems associated with the respiratory tract, it can cause an attack. This is serious. It happens all around the world. Lots of cities in the United States have below U.S. air quality standards on certain days, and it has to be dealt with. In developing countries, the problem is way worse. Do you guys remember when the Olympics were in Beijing? There was a big controversy about even letting Beijing have the games because their air quality was so poor due to brown air smog. Now, what did they do to fight the problem? They banned cars. In the city of Beijing, they banned automobiles. The regular old citizen of Beijing was not allowed to drive for a whole month before the Olympics came. Now, the government provided more public transportation to ease that pain, but incredibly, they actually banned cars from the city for a month to cut down on the nitrogen dioxide that would result from all of those tailpipes. This is a problem in Denver, Colorado, another place where there's lots of sunshine, lots of cars, and that city sits in a bowl. You may think of it as the Mile High City, as if it's somewhere up on top of the mountain. But anybody that's been there can tell you that Mile High is surrounded by much higher mountains all around it. So that bowl effect makes them a prime suspect for photochemical smog.
Human activities add a number of pollutants into the air. Soot and sulfur dioxide are produced by the burning of coal and oil. Nitrogen oxides, carbon monoxide, and volatile organic compounds, known as VOCs, are produced by internal combustion engines. In bright sunlight, primary pollutants such as nitrogen oxides, carbon monoxide, and VOCs are converted by photochemical reactions into secondary pollutants, such as ozone, peroxyacetyl nitrate, known as PAN, and aldehydes. Normally, these pollutants would rise high into the air and be dispersed by winds. However, when a cool surface layer, such as a sea breeze, is trapped by a descending warm air mass, a temperature inversion layer can form.
This is exactly the kind of picture I have in my head when I think of California, with the big mountain ranges over here on the sides, trapping all of the emissions, whether it comes from factories, power plants, or from cars.
Temperature in the inversion layer increases rather than decreases with altitude. This inversion layer acts as a cap, trapping the pollutants close to the surface. The result is a brown, hazy layer of photochemical smog. Mountains around an urban area can further aid in the trapping of pollutants.
Those other chemicals that are mentioned in the video, write them down. PANs, peroxyl aldehydes, are also part of the problem. They're not shown in this diagram, but they are also secondary pollutants that aid to the photochemical smog problem. VOCs are an issue? Certainly. But I want you to remember, I'm trying to make this easy for you guys, I want you to remember the nitrogen dioxide, the sunlight, and the ozone. Those other things like PANs are an issue. You will see that on the ACE exam and the AP exam as secondary pollutants that are part of photochemical smog. But I want you to remember the ozone. That is the big one. Nitrogen oxides are put out into the atmosphere by smokestacks. That's true. But I want you to remember cars. That's the biggie. Have some pictures here just to show you what photochemical smog looks like. This is LA, and you can see why this was such a concern for people over the last 30 or 40 years. It's a complex chemical reaction that happens in the air. Don't get me wrong. I'm trying to simplify it as best I can for you. But it is a serious problem. Ozone in the troposphere. Here's another picture. Here's Denver. As I mentioned, Denver is a prime area for photochemical smog. Mexico City, I think I have a picture of that. Mexico City is the poster child. It's the worst. In fact, Mexico City's gotten to the point where when they have particularly bad days, and again, why are some days worse than others? That thermal inversion thing can happen. But Mexico City is in a bowl. And when it's in a bowl, there's mountains all around it. And those mountains hold in everything that goes into the air from every car, from every smokestack. And it just sits. That nitrogen dioxide turns brown and forms ozone. Mexico City gets so bad that they actually have days when you get up in the morning, you have to find out whether or not you can drive to work today. Because on particularly bad days, they will just put up barricades around the city and say, no cars here. And they're trying, they can't control the sun, so they have to find a way to control the nitrogen that gets into the air. And they also have rolling blackouts, so no nitrogen from smokestacks gets into the air. I don't want you to think about smokestacks when it comes to this issue. I want you to think cars. There's Beijing before the Olympics. You can understand why countries around the world were complaining when Beijing was awarded the games. They did clean it up, though. The air quality was pretty good for runners and so forth when it came to those summer games. All right, the second kind of smog is known as industrial smog or gray air smog. Okay, this is different than the brown photochemical smog because the sun isn't part of the deal. But instead, what is part of the deal is sulfur. You've got, let me see if I got, no, I don't. Sulfur is the main culprit in industrial smog, and it's sulfur that gives the gray look of smog. Industrial smog, we've pretty much done a good job to control in our country because, as I've mentioned to you several times already, we have found good techniques to control the amount of sulfur that comes out of the smokestacks in factories. But some sulfur still gets out. Back in the day, this was the most common smog you heard of. It was a gray sort of smoke that hung over industrial areas. Pittsburgh would be a good example. Places like that. Chattanooga had the problem. Industrial or gray air smog. Different than photochemical. No sun is involved. It's just the sulfur oxides that get up into the air, putting a haze over the city. There is one additional thing with gray air smog, and that is many more particulates are in the air with gray smog. Remind me to show you these videos tomorrow in class. This diagram that's at part of the screen here is just once again showing you different examples of particulates that can be in the air. And remember, we talk about microns or micrometers when we talk about the size of the little particles that exist. You can see even tobacco smoke, people are breathing in, and that's why we've gotten rid of smoking in a lot of public places. Humans are breathing in particulates from other people smoking their tobacco. Alright, the last thing to cover in this section is about thermal inversions. Thermal inversions can contribute to the photochemical smog issue, but they're their own separate thing, and that's why I want to spend time on it right now. The big problem with thermal inversions is the topography. So even a city that doesn't have a lot of pollution, doesn't have a lot of cars, can have an air quality problem because of a thermal inversion. Once again, topography matters. You've got a city that sits in a bowl. To me, this picture makes me think of Denver. The city that sits in a bowl, and ordinarily all of the pollutants just get up and they rise up into the atmosphere, and truly they get up above the mountain range, and then when the air circulation moves, it pushes these pollutants out away from the city, and so it doesn't cling, it doesn't hover, it doesn't stay. But there will be, I don't know, 20 days during the course of the year, many of them are summer days, in which you'll have an unusual occurrence. Ordinarily warm air rises, right, and that will take the particulates and the pollutants up with it, and then the jet stream will just blow it out. But every now and then what happens is a cold front comes in over top of the city, and it causes this thing called an inversion layer. What ends up happening is warm air from all day long around the city that used to rise up gets trapped. The warm air stays where it needs to be. You know, people in the city probably think, oh good, it's actually warmer in our city tonight, we're going to have a nice day tomorrow. But what ends up happening is, even though their temperatures are warmer, the pollutants aren't able to, and the warm air is not able to rise above this cooler thermal inversion. This cooler air mass is like a lid. It's like a lid that holds everything in place in that city. Notice the mountain ranges on each side, so there's just no escape for all of the pollutants that were added to the air all day long. They don't clear out at night, so when people get up the next morning, they are faced with a really nasty air quality situation. That's called a thermal inversion. I hope you understand it now. Warm air during the day, this is the normal everyday thing. Warm air rises, takes all the pollutants up with it, and as the warm air rises, it cools and the jet stream takes it away. But the warm air is not able to rise when a cold front moves in. The timing is important. The timing has to happen right before nighttime. The cold air mass comes in and puts a lid on what's supposed to leave the atmosphere. Okay, I've got those other videos to show you. Smog is a major environmental issue. It's a major health issue, especially for those people that have breathing problems. If you're a kid that carries around an inhaler, You need to think twice about what city you might move to as you get older. Is this a problem in Florida? Once again, remember, your experience is not the average experience. You don't know what it's like to grow up wondering if you're going to school tomorrow because of the air quality. We don't have mountains blocking our air masses. Our area is so flat, it wouldn't matter how many cars were driving, how sunny a day it was. Photochemical smog would not be an issue for us because it can blow out. Alright, that's it for smog. The next topic is going to be acid deposition, and that one is a biggie. This one's nice and short because the next one is going to be nice and long. See ya.